Thank you, Fiona, and thanks everyone for joining this session today on running your business critical applications on the cloud. As Fiona mentioned, my name is Shailesh Albuquerque. I work out of Bangalore, India, and I work with a lot of enterprises, small, medium, and large, helping them design their applications, their business critical applications on AWS, and also helping them migrate onto the AWS Cloud. So since you've joined the webinar, we've made some assumptions about who you are. We think that even you are looking to deploy your business applications on the cloud today. You may already have these applications running within your data center, so you may want to migrate them onto the cloud. You would like to understand the migration approach that we see in a typical enterprise or in a small and medium business. And you would like to understand some architectural patterns, some tools for migration. So we've prepared an agenda to cover some of the topics that we spoke about. So what I'll do is first talk about why choose AWS for running your business critical applications. Then we'll go to some common enterprise applications that we see predominantly from SAP, Oracle, Microsoft. And then I'll talk about how these are supported, what's the licensing model, and cover that briefly. We'll then go into a typical enterprise migration path. What do we see enterprises do, and how do they leverage the AWS Cloud? And we'll go a little more deeper into the technology architecture, and we'll talk about some architecture patterns that we see when enterprise applications are deployed. And then we'll cover some best practices and tools for migration. So we have a packed agenda. And I'll be taking pretty much the entire hour. So at a particular section, if you have some questions, if you'd like to get some more clarifications, feel free to post your questions in the questions panel. We have panelists standing by to answer your questions right then and there. So do not wait till the end. So let's begin. Now we know that many businesses are adopting AWS Cloud for some of the traditional value or business benefits that cloud provides. And these are agility being one. Businesses can run their applications very quickly on AWS. There is benefits of trading your capital expense to an operational expense that mirrors the demand or the growth of your users. So that's a nice benefit to have. We also see the benefit of being able to scale up when you need to, and then scale down whenever you need to. So that's some of the benefits of running any applications on AWS. But today we're talking about some of the hardcore enterprise business applications. So why is AWS a good choice for these? So I'll spend some time to explain why AWS is a platform of choice when it comes to cloud when running business critical apps. The first one being the spread of the AWS Global Infrastructure. So we have 11 regions. We have 28 availability zones. These regions cover the entire globe. We have 4 in North America, 1 in South America, we have 2 in Europe. Within APAC, we have in Singapore, Sydney, and we have Tokyo. China is another region, and these regions allow you to deploy your applications to any geography. So when you create an account with AWS, you are no longer constrained by your geography or your data centers, but you can take your business application and deploy it based on which is the closest location, maybe for your users, for your customers, maybe for your partners. So this is a great benefit of leveraging the cloud, the global reach that it provides. And the second immediate benefit is as you move to the cloud, you improve upon the fault tolerance and the disaster recovery abilities that you obtain as an enterprise. Now, how this is achieved is through the concept of regions and availability zones. So I mentioned about our globally distributed regions. Now, each region is an independent collection of AWS services, and these are a collection of data centers within a large metropolitan area. Now, each region also contains 2 or more availability zones. So these availability zones, these are distinct locations, and these are engineered to be insulated from failures in another availability zone. So when you deploy your business critical application, you have an automatic choice, a ready available choice of deploying this across multiple availability zones. This could be as simple as creating a primary stack in one availability zone and having a backup snapshots or some of the archival in another availability zone, and being able to spin up the application quickly if there is a fault in one of the availability zones. This could also mean that you could run this in a highly available mode, running parallel stacks in 2 or more availability zones. This improves the fault tolerance and disaster recovery availability significantly, and this is a fraction of a cost than having to invest in an entire new data center for a secondary site. Now, as you go deeper within the AWS services, we see that most critical applications need good performance from the compute as well as from the storage services. So we're talking about 2 services that you use on AWS EC2 and Elastic Block Storage, EBS. And here, AWS has been constantly innovating to provide better and faster high-performance EC2 instances. You have the different families of instances, general purpose. If you need more compute, there is compute optimized. If you need more memory, for example, if you would like to run a database or an in-memory database, you typically need more memory when compared to compute. We have instance families that are tailored for this need. There's also instances that can be used for very fast NoSQL type of databases which need high I/O. We also have instances that can be leveraged for running data warehouses for enterprise applications. Could be storage optimized instances which have large high sequential I/O with large block sizes. Also, we are seeing some new instances being deployed for our customers, and C4 instances are the new instances that are available now, and these are based on the Intel Haswell technology. These are designed specifically for EC2, and this gives you better performance than what is really available within your data centers when it comes to compute. These instances are important because if you take applications like SAP, SAP works a lot on benchmarking instances, ensuring that they meet a certain rated specification. So the family of C3, R3, C4 instances, they're all benchmarked when it comes to workloads like SAP. Similarly, on the storage side, there are different flavors of storage technologies, EBS magnetic being the traditional choice. But since then, we've also developed high-performance storage, and this is within the Elastic Block Service, Elastic Block Storage Service. So we have the general-purpose SSD today. These are provide a good price performance with burstable I/O going up to 3,000 IOPS per 1 terabyte volume. So this can be used for a lot of business applications. And similarly, if you are running a database that needs a lot of disk performance and you would like guaranteed IOPS or consistent IOPS, you could use provisioned IOPS out of our block storage. These go up to 4,000 IOPS per volume, and you could also RAID multiple volumes together to get many multiples of 4,000 IOPS. So we are seeing a lot of very high performance, high compute, high storage databases, applications being deployed, and running these is no longer a barrier on the cloud. Beyond the instance and storage, it's also important to have a high performance network, and AWS has made considerable strides on providing a high performance and enhanced networking features within the VPC service that we have. So this gives you high packets per performance, and gives you low jitter, and these are based on Intel's single root I/O virtualization technology, which helps you have faster, better performing network. If you would like to connect several EC2 instances within a cluster for some of the high performance workloads, then you could also use the option of placement groups within VPC, wherein you can have all these EC2 instances in a logical placement group and get up 10 Gbps of bidirectional bandwidth between these instances. So we see a lot of enterprises running their high performance clusters, their bioinformation processors, genome processing. So all this is being done today. These are business critical apps that are being deployed on the AWS Cloud. Next, when we talk about business critical apps or enterprise apps, security becomes an important discussion. Most often, these applications contain data that needs to be compliant with regulatory standards. It could be financial information, it could be health information or card information, employee data, and hence here you would need to demonstrate compliance with various security standards. It could be PCI DSS or it could be ISO. So when it comes to security, AWS has led the way when it comes to cloud security. So AWS is already certified for a lot of these compliances that are relevant for your regulatory environment across all of our regions. And going beyond that, we advocate what we call as the shared security model, where AWS provides security of the infrastructure that we deploy and run. Customers need to take care of securing their applications and their data. But we've been providing certain services and tools to make that easy for customers today. And some of the primary features that have been released and the services that have been released over the past year is the key management service that's used to create encryption keys and use that to encrypt data and use within some of the AWS services. The services such as S3 used for object storage, EBS which is used for block storage, and relational database service, the RDS service that is a managed database for several database engines including MySQL, Postgres, SQL Server, Oracle. You have encryption features built in a lot of them. You could also use features such as transparent data encryption for some of these databases. Hence, placing your critical data, your compliance sensitive data on AWS is no longer a barrier because you could use this native encryption features. And going beyond encryption, there is also a need to demonstrate logging, auditing, and compliance with regulations. So AWS has features such as AWS Cloud Trail. This is a service that gets a complete audit of log and audit of all the changes that have happened within your AWS environment. So you could easily demonstrate to your auditors that security and compliance is managed consistently across your own data centers and also in the cloud. Most enterprise applications do not live in isolation. They need to integrate with several different applications, be it within your own data centers, maybe data centers that are globally distributed within your own enterprise. It could be third-party data centers, maybe suppliers and customers. So it's important to have techniques and tools that let you integrate your cloud resources with on-premise or with other data centers. And here AWS gives you a whole host of technologies, be it facilities to manage your migration of virtual machines and data, the ability to manage resources on the cloud and also on-premise using a single pane of glass, the ability to leverage your own identity stores, be it Active Directory or an LDAP, to ensure that authentication and access control is applied consistently across all your services on the cloud and also within your own data center, and the ability to connect securely. So these are techniques that you need to connect to the cloud and have seamless integration. I will be discussing a lot more on this as we dive into the architectural patterns. And most enterprise applications and business critical applications need access from around the globe. You see a highly mobile workforce today that needs access to these applications from wherever they are. Maybe they are working, traveling, or using different devices. So AWS is now releasing a lot of features within the enterprise collaboration and sharing suite. So there are services like Amazon Workspaces. These are managed desktops on the cloud. So you could create a desktop for either your staff or your outsourced staff or your partners who can then access it securely through their clients, through their devices, mobile devices or tablets, and then use that hosted desktop to access critical applications, hence have secure connectivity end-to-end and not risk your infrastructure to be exposed at the network level to various different parties. Also, when it comes to collaboration and sharing documents, Amazon WorkDocs is a service that you could leverage. And finally, a key feature of enterprise apps is the ability to use a lot of third-party solutions to complete or augment the business critical application that you're running. It could be some reporting software, it could be certain security software that you would like to run, maybe a load balancer, and so on and so forth. So in this space, AWS has the marketplace where our partners and independent software vendors, they list their application or their solution, and these can be deployed within your environment at a click of a button without having to deal with many different vendors, to integrate, to procure, and to configure and deploy this option. So you could run analytics software such as MicroStrategy, JasperSoft, or you could run security solutions such as Trend Micro and network solutions such as Citrix, F5, all within the comfort of your AWS console and from within your AWS account. So this is a great reason why enterprises are choosing AWS today to run their business critical applications. So I hope I've made the case for why AWS is becoming the default and the strategic choice for running critical apps. Now let's look at some of the critical apps that enterprises typically run. Usually they fall into the apps supplied by the vendors that you see, SAP, Microsoft, and Oracle. And there are many others, but we'll take these three examples and we'll talk about what's the support that's available, what's the licensing model look like, and then we'll also talk about architecture later on. So let's first talk about SAP. SAP and AWS have been a partner for a very long time now. Most of the SAP solutions today are supported to run on the AWS Cloud. This begins with their flagship suite, that is the SAP Business Suite. You could run it in a production environment. We have instances that are benchmarked to run SAP for various SAPs ratings. You could check with us to know more about it. And also when it comes to SAP, a choice for running SAP databases is SAP HANA. SAP HANA can also be run, it's fully supported and can be run in the production deployment. This can be used for business warehouse or for business suite. So this is all in a certified production supported environment on AWS today. As we look at small and medium enterprises, Business One is a smaller ERP solution that a lot of small and medium enterprises leverage. And Business One could be deployed very quickly on AWS and you can be up and running in a matter of hours. Similarly, there are other solutions such as Business Objects for reporting. There's rapid deployment solutions. There are solutions from the mobile device management space called Afaria, e-commerce for Hybris. So all this can be run productively on AWS today. A note about the supported databases and OS when it comes to SAP. So SAP typically runs on the enterprise Linux or the Windows versions. SUSE, Red Hat, and Microsoft Windows Server are the supported operating systems. All this can be run fully supported on AWS in an on-demand mode. That means you can pay for the OS and also for the instance on an on-demand basis. And for databases, SAP HANA is becoming a choice for a lot of the SAP software today. But you could also run it on the relational databases, the traditional ones, that is DB2, MaxDB, SQL Server, Sybase. There's one notable exception. The Oracle DB is not supported by SAP to run in a production environment on AWS. Now this is an SAP restriction. You could run Oracle database otherwise, and I'll come to that a little later. But you could run this in a non-production environment, that is test, demo, POC, training, etc. When it comes to licensing, most of these vendors have a common theme, and that is some of the licenses are available on demand. That means you can buy it as a license included option when you run their software on AWS. In the case of SAP, the license included options are really not that many. You have a few software available on the AWS Marketplace. There's Business Warehouse BW. There is SAP HANA Business Edition, but primary model has been to bring your own licenses, which means that if you have procured licenses and you are running SAP in your own data center, these are fully portable. That means you can deploy your software on AWS and apply those same licenses on AWS. And this has been the choice for a lot of the applications, including Business Suite, All-in-One, SAP Business Objects, etc. Let's move on to the Microsoft stack, and here we see customers running typically Windows Server and multiple applications on top of Windows Server. Microsoft SQL Server database, which is a popular choice. There is applications such as SharePoint and Microsoft Exchange that we have a lot of enterprises running on AWS today. And then you also have the business applications such as Dynamics for ERP and CRM that can also be run on AWS. Another important typical feature when we look at Microsoft enterprise applications is a lot of the custom-built .NET applications. These are usually a part of the stack. So we've made it easier to run and deploy .NET applications on AWS today. We provided a software development kit that you can actually include within your .NET libraries and use AWS services. We have a toolkit for Visual Studio, which means if you're using Visual Studio as an IDE for developing applications, this AWS toolkit lets you control and manage the AWS resources from within the Visual Studio. If you're using PowerShell for automating your tasks on Windows environments, then you could use AWS within AWS tools within PowerShell, and we have included that. So this means you can do things like starting, stopping instances or launching instances using PowerShell. And finally, if you want to just deploy a .NET application without having to go through the process of provisioning or creating load balancers and databases, this is something that you could just use our Elastic Beanstalk container. Now this Elastic Beanstalk container provides a .NET framework or a container for you to run your applications without having to actually deploy or launch instances. So this becomes an easy choice. From a licensing standpoint, we have software and license included for the options that I've provided there. For Windows Server, we have images that you can launch instances with Windows Server and SQL Server combined. This can be Web Edition as well as Standard Edition. So this quickly lets you launch a Windows operating system plus a SQL Server on top of it without having to install SQL Server separately. Also, we have the relational database service. That means the option of AWS managing your database as a service, and we provide a SQL Server engine for relational database service with a Standard Edition license. There is also the option to bring your licenses through license mobility and through software assurance. So this includes software such as SharePoint, Microsoft Exchange, and other Microsoft products. From Microsoft, we'll quickly move on to Oracle, and again here, Oracle and AWS have had a long relationship. Oracle has been was one of the first vendors to come out and support running Oracle software on the cloud. So Oracle databases are fully supported on AWS today. We have several enterprises running Oracle databases either on EC2 instances or leveraging the relational database service, where we create, configure, run, and manage the database, and you could run it as a managed service. There are different replication engines for Oracle, DataGuard, Golden Gate, so these can also be run on AWS. These are fully supported. The Oracle Fusion middleware stack, so this includes some of the middleware services including WebLogic, the SOS feed, identity and access management. So these are also fully supported on AWS. And then Oracle also has a whole host of enterprise applications, ERP for HRMS, include eBusiness Suite, JD Enterprise, Siebel. So we have enterprises that run Oracle applications on AWS today. These are supported on EC2. There is a caveat though, these are supported on OVM as per Oracle's support policy. Now if you'd like to know more about that, and if you'd like to understand how to run Oracle applications on AWS, please get in touch with us, and we will be able to help you with that planning and design and making sure that you are fully supported on that. So that's regarding the Oracle software. The license options for Oracle are typically just like any other vendors. All Oracle licenses are fully supported. These include the end-user licenses, the OTN licenses, and there is an Oracle Cloud Support policy that you can read online. And also there is a FAQ for AWS specific questions that you can read on the Oracle website. So this will answer some of the frequent questions you may have as far as running your Oracle software on AWS is concerned. Now, besides Microsoft, SAP, and Oracle, you can also run software from several other enterprise vendors. It could be IBM, Adobe, Infor. I'll not go into details of all of them. So the theme is common. Most of these are supported on AWS. Most vendors have a support policy. They have a license mobility policy. So you could check on our website or you can get in touch with us. But now let's get into some of the patterns and some of the approach that enterprises adopt. So we see enterprises adopt AWS in several ways, and we have tried in this. I'm showing in this slide what are the ways in which enterprises adopt AWS. And if you look at it, there is an x-axis which shows what value that is provided back to the business, in terms of cost saving or agility. And also on the y-axis, the time it takes to execute on a particular option. So if you see here, there are 4 categories. One of the easiest ways to get started is archiving. AWS provides highly durable storage options. S3 is an object storage technology that is low cost, high scale, and you could use it to archive your data on the cloud, and if required, then restore it back within AWS or to your own data centers. Most backup and archival software providers today, be it Commvault or Symantec, they provide plugins that directly interact with S3 and Glacier, which is our storage service that is at a lower cost, and it's meant for archival. So you don't have to do a lot of work here, because it's just a matter of looking at your enterprise backup software and then getting the appropriate module that works with S3 or Glacier, and then using that as a target for your archival data. Oracle supplies a module for RMAN, the recovery manager, used to back up Oracle databases, called Oracle Secure Backup. It just writes data to S3 directly. So that's an easy way to get started. But as you see, the value may not be high because you're still running a lot of your infrastructure within your own data center, and the efficiency may not be that high. The second way is to run it as a disaster recovery site. And so here the pattern is quite interesting. I'll get into more details later. AWS can be just used as a disaster recovery site. The production application can continue to run within your own data centers, but you can run a small footprint only necessary to keep the lights on your disaster recovery site. And whenever there is an event or an incident, you could blow up that infrastructure on AWS, and you see that the value that brings to business is higher because you don't have to now invest in a complete secondary site. A third option is to run test development and POC workloads. A lot of the enterprise applications, and specifically if you consider SAP, the production environment could be one environment, but there could be several other lower environments used for test development, could be used for training, could be used for proof of concepts, things like that. And these are variable in nature, which means that you don't need it running 24/7 and throughout the year. So with AWS, you can run these environments on demand, shut them down when you don't need to, and get a higher value to your business by using only what you need. And then the last phase, or the place where you get the highest value, and that is running your production environments. This will give you true agility, the ability to deploy applications faster, the ability to scale up and down as your business demands. So these are 4 different patterns we see enterprises using AWS today. I'll go a little more deeper into the technology architecture for them. So we'll now start looking at what is the architecture pattern that enterprises start off with and how they evolve their architectures. So most enterprises, be it small, medium, or large, start off using a virtual private cloud. It is a default choice today when you run on AWS, but we recommend that you give careful consideration in designing your virtual private cloud. And a virtual private cloud is the ability to create a virtual network within AWS. And you can then launch your resources, be it your databases, be it storage, be it instances within that virtual network. This virtual network gives you a whole lot of control over the environment, which means you can select your own IP addresses, which is an extension of your IP addresses within your own data centers or within your site. So this can just be another subnet that you carve out of your global IP range within AWS. You could create different subnets, configure them maybe as a demilitarized zone with access to the internet for internet access, or you could keep them completely isolated from the internet and have just an internal subnet. So these are almost like VLANs that you create within your own data centers. And VPCs also give you a lot of granular control for routing, for DNS. So you could look at creating a VPC to begin with and just extending your data center into AWS. An easy way to connect your data center into this VPC is through an IPsec VPN. We provide a virtual gateway that you can connect to your own firewalls or VPN gateways and have an IPsec VPN and quickly get started. So this gives you a secure network that you can connect from within your data center into AWS. Now you can extend this, and as you start using more and more resources on AWS, as you need to, if you need to send more data into AWS or exchange a lot of data back and forth, then a good option could be Direct Connect, because when you run an IPsec VPN, you're leveraging the internet connectivity, and this may not be consistent or it may not provide you a high throughput. So you could actually establish a dedicated network connection between your own data center and an AWS Direct Connect location. And from the Direct Connect location, you can have a 1 Gbps or a 10 Gbps Ethernet link within it to your AWS VPC. So this uses the 802.1 VLAN technology. You can create multiple virtual interfaces and connect them to different VPCs that belong to your own enterprise. And you could use BGP for exchanging routes between your data center and AWS, which means that you can have multiple redundant links, ensuring that you have a high degree of connectivity and availability for your network connectivity when you connect from your data center into AWS. So this is something that you can plan as your data needs and your network requirements increase. Now, when you bring in enterprise applications, some of the other foundational building blocks could be directory service. Now, AWS has launched a directory service that lets you create a directory service on the cloud within your VPC, and lets you connect back to your own domain controller and connect to your on-premise resources. So this is the AWS Directory Service. You can also have a lightweight standalone directory where you can have your EC2 instances connect to this directory for things like group memberships, joining a domain, for Kerberos single sign-on, group policies, etc. This becomes necessary for some workloads such as Microsoft SharePoint, or if you're using critical applications that need to leverage your internal or your corporate credentials. If you want a full-fledged directory with all the bells and whistles that Active Directory provides, then you could also plan on launching your own domain controllers within the VPC in a redundant fashion. If you see here, there are two in both availability zones, and connect them back to your AD within your own data centers. This lets you have use cases that support software such as Microsoft Exchange, and some places where you need a higher level functionality of Active Directory. So you could have your multi-master read and write domain controllers, or you could have just read-only domain controllers, depending on how you would like to delegate access to AWS. So these are the foundational building blocks. So I've built upon starting with the VPC all the way to having a full-fledged directory service as a foundational service. The next, so once you have a VPC created and some resources, you can think about having the different patterns. And so one of that I mentioned was database backup to AWS. This is a very simple pattern where on the left of your screen you see we are using an Oracle database with an Oracle secure backup Oracle RMAN module that just directly writes data into AWS S3. Oracle secure backup could be one way of shipping data to AWS. You can also have other gateways such as the AWS storage gateway itself, and then also Riverbed, and there are several other vendors who provide these gateways that let you write data to S3. Now, this can be used for purposes of archival or also recovery. So in case there is a failure on your corporate data center, you could spin up an EC2 instance and recover the data from the S3 or from the cloud. The second pattern I mentioned was a disaster recovery site on AWS. Now, this is the architecture pattern that you see. To your right of your screen is your maybe your own data center or a colo that you're leveraging. So all the traffic is actually going to that primary data center where you have your web server, app server, and your database. And if you see on the AWS to your left, there is just a small database server which is handling database synchronization or replication traffic. There are several ways that you can configure this replication. And there are freeze-dried copies of your EC2 instances. That means these are images that have the code and all the binaries that you need whenever you need to start your application on AWS. So whenever there is, let's say, a disaster or a severe unavailability on your primary data center, you can just spin up EC2 instances for your web and app server and have the database server to be a fully functional high-performance EC2 instance that can take up all the load, and now you can run your site on AWS without having to really run a secondary data center. This is a very efficient way of running. We call it a pilot light architecture. It's a very popular way of running disaster recovery on AWS. As you run your production application or even your test and dev applications, the pattern that you see on the screen is what you can leverage. Primarily for test, dev, staging, where you don't need high levels of availability, you need option to recover if in case there's a failure. So this is running your application in one availability zone. You see a web server, app server, database server. You mentioned Oracle, it could be SQL Server, it could also be a relational database service that you can use for Oracle or SQL Server. And here backups are periodically taken and stored on S3. Even snapshots are stored on S3. Snapshots being the copies of your EBS volumes that have the operating system data or could be also the application data. Now, whenever there's a failure, you could quickly recover in a second availability zone or also in another region because you have the ability to copy the snapshots from one region to another. This is a good pattern for applications that do not need a high amount of availability. This is primarily for test, dev, POCs, etc. You can maximize minimize the cost of running and maximize efficiencies here. And finally, when you're running an enterprise application, a business critical application that you care about the availability, making sure that it's always up, this is the pattern that we recommend. So here you are running your application, spreading your instances across multiple availability zones. You have web servers deployed in both availability zones, and as I mentioned, availability zones are isolated from one another. They're many miles apart. You also have application servers. You could use load balancers, either the Amazon load balancing features such as Elastic Load Balancing, or also you could use third-party load balancers such as Citrix, Netscaler, BigIP, F5 to configure load balancing between these tiers. You could have a database server running in one of the availability zones and have a replica set up in a second AZ. In this case, we've shown Oracle. You could use DataGuard or Golden Gate to replicate. Also, if you use SQL Server, there is SQL Server mirroring. There's always on availabilities. So there is a lot of different features that let you have high availability at the database tier. So this lets you run an application in an uninterrupted fashion. This is a good pattern for enterprise apps. If you have the ability, you can also configure auto-scaling. This is a feature where you can add more resources or instances automatically when the load increases. I've shown this for this web and app servers. Depending on the applications that you use, it may or may not support auto-scaling. That's a choice you can do. You can leverage when you design this application. So as you go ahead, you can see you can have complex or sophisticated application patterns. So this is a reference architecture for SharePoint. And this is available on our website. You can download it from our reference architecture architecture section. So here you see that there's a VPC that is running across 2 availability zones in a region, and then there are 8 subnets, 4 in each availability zone. Each of the SharePoint role, that means SharePoint has different servers to perform different roles. They are in a different subnet to ensure isolation and security. And the public subnet is exposed to the internet with a load balancer in front of it. This can be very easily set up. In fact, in the last subnet, you'll see that there is directory servers and also database servers also are available in multiple subnets within and in multiple availability zones. So this is a highly available SharePoint farm deployment. You could create this VPC and create all these instances, and it may take you maybe a day to create all of this, or you could just use something called as a reference architecture and CloudFormation templates. Now what we've done is some of these key enterprise applications like SharePoint or HANA, we've deployed or we provided CloudFormation templates. Now these are tried and tested pre-configured stacks that you can download, and the click of a button you can launch it within your account. So this particular SharePoint stack, it takes about 3 to 4 hours and deploys itself automatically without you having to do anything. So you can imagine you can run a full-fledged SharePoint farm in a matter of hours using a CloudFormation template. If you're running your own applications, you can actually go ahead and create a CloudFormation template of your own, and you can use that to create more and more stacks, specifically in test and dev environments or POC training environments, etc. So we have a lot of white papers and quick start guides available online. Some of these white papers talk about how to deploy enterprise applications such as SharePoint, Exchange Server, Windows Server clustering, SQL Server, always on availability groups. White papers for SAP are available. For Oracle, there are several white papers that talk about how to run a high-performance Oracle database, how to replicate data, so on and so forth. And as I mentioned, the quick start guide, these are architecture reference guides plus associated CloudFormation template that actually lets you go ahead and create the entire stack in an automated way. So we're coming to the last section of this webinar, and this talks about migration approach and some of the best practices. And the first step that we see a lot of enterprises and small and medium businesses take is actually trying to estimate their cost of running their resources or their servers on AWS. And here itself, there's a lot of do's and don'ts. There's a lot of recommendations that we have in calculating your cost. Typically, we call it calculating your total cost of ownership, where we advocate that you don't just look at cost of your servers or storage in isolation, but look at the total cost of running everything. It includes services, backup, people, licensing, and all of that. So some best practices when calculating your total cost of ownership. It's very easy to get started on AWS using on-demand. On-demand lets you create an instance and run it without any commitments. The minimum commitment is an hour, and let you pay for that usage. But as you compare cost of running on AWS and within your own data center, and typically for this enterprise application, which seem to be monolithic sometimes, steady state, running for long durations, you could look at models such as reserved instances. So we have 1-year and 3-year reserved models. If you use a 3-year reserved instance, that means you're committing to a certain capacity on AWS, and you could have an option of paying upfront either the full amount or a partial amount. Also, you can not pay but just commit for the capacity. Depending on what option you choose, you get significant discounts, a significant reduced rate on your running cost. It's important to compare costs by using reservations so that you get a true estimate of what's your cost of running your application for a longer duration. And there is tiered pricing on AWS, which means that as you consume more, if you use more network I/O or storage, you do get benefits of lower cost as the tiers increase. There's also a lot of cost of automation. So when you're running, let's say, a test and dev environment, or you're running an application that scales up and down, you could actually use auto scaling or use some scripts, and that means you don't have to calculate cost for not running your environment. So this is important. Some of the things you should not forget to include in your cost when you're doing the analysis on your side within your own data centers is not to forget to add the cost of power cooling. Somebody is paying that cost within your own data centers. Cost for licensing, for example. So there are a lot of these hidden costs that you really incur when you run within your own data centers that need to be factored in when you do a true comparison. There's a lot of additional intangible costs or benefits that you get when you run on AWS. That means you can deploy your applications and be able to serve your customers, start getting revenues immediately. So these are bonus that you have to include in some way to show that there is a increased benefit of moving to AWS. So these are some things that you can include within your TCO analysis. There's a lot of help available in terms of calculating TCO and calculating costs. So some of the links on the website will take you there. The Economic Center is a good place to start. Now, as you think about moving applications or migrating, a key criteria becomes which applications do I choose to move if you're already running a lot of them within your own data centers. And here also we have some recommendations. We know what patterns work well. Some of this I'll be able to share with you today. A lot of this is available again as white papers. There is a white paper just on migration on our website. So standalone applications, they don't have a lot of dependencies within your own data centers or software dependencies within your own premises are easy candidates because they can move easily. So always think about moving your standalone applications first. These are easy to move. Now applications that talk to each other using services-oriented architecture, which means you're not running maybe RPC calls or Java calls directly between applications, but using a layer of abstraction using web services. If you have applications such as that, loosely coupled, these are good candidates as well because you can take that portion out, put it onto the cloud, and these SOA-based services are highly tolerant of network latency and things like that. So these are again good candidates. If your applications are tightly integrated with certain on-premise components or certain hardware components, then this may need some more planning. So there are ways in which you can identify good candidates to migrate. A key recommendation that we always make to our customers who are planning this migration, who already have applications within their own data center, and even if you're trying to build a new application within AWS, is to just run a proof of concept. Now, proof of concept is just take some resources, may not be a full-fledged stack or large instances, but take small instances, deploy a version of your application, and this will give you a lot of confidence being able to validate whether the application can run, can install. Beyond that, you will also identify what could be the gaps, maybe in services or in technology that you may have to consider or work around. It gives you a good idea of what are the skill sets you may need when you want to run this at scale and want to manage this. How you can monitor the applications, how to integrate this within your own monitoring system. So there's a lot of questions that are answered by investing in a proof of concept. It's very easy to do a proof of concept on AWS. You don't have to call a vendor and ask them to ship hardware and place them within your own data centers. You can create an account and start spinning up your resources and start testing. Once you've decided to move, there are best practices in moving data. This could be moving data, which is files from your own data center into AWS. It could be database backups, or it could be virtual machines, moving virtual machine from your own virtualized environment into AWS. And here there are several options that are available based on the amount of data that you have, the time you want, the time it takes to move the data, and how quickly you want to migrate. So this is not an exhaustive list. You can find a lot more of this again on the white papers, but I'll just call out some important ones. So if you're moving files over the network, which is a pretty good option if you're dealing with a few terabytes, maybe less than a terabyte of data, you could use services such as Aspera, Attenuity. There's also some open source utilities such as Tsunami UDP that you can leverage. Now, if you are just moving backups into AWS and really just using AWS to restore that backup and spin up an environment, then a lot of the backup software that is provided by vendors, they use plugins that talk directly to AWS. This includes software like Commvault, NetBackup. You also have technologies such as ArcServe from CA that let you copy the data or mirror your virtual machine directly into AWS. I've mentioned about storage gateway before. This is a gateway which is a virtual appliance that can run within your own environment, whether it's Hyper-V or whether it's VMware ESX, and you can point all your data to go to the storage gateway, which then can move this asynchronously into S3. There are different modes of running storage gateway. You can run it as a cache volume, you can run it as a stored volume, or you could also run it as a tape volume, which writes data into S3 and archives it as a virtual tape onto Amazon Glacier. If there is a lot of data in the order of a few terabytes and you want to move that fast, you could just ship your disks. That means you can put your data into a USB or a SATA drive and ship it using a ground shipping service, and this will be taken by AWS, and we could make this data available within your account. And this is a very easy way to move a lot of data to get started off on AWS. There is also database backup tools that I mentioned, Oracle Secure Backup being one. Replication tools that replicate data either at a database level or at a block level. Golden Gate is something that you can use to replicate databases. We have DRBD that can be used for block level replication. You don't see it on the screen here, but we mentioned it in subsequent slides. And similarly, if you want to move virtual machines right from your own environment, just want to drop and ship your virtual machine and make it run on AWS, you can use the VM import export service, so which means you just import the virtual machine and make it run as an EC2 instance. If you're using VMware, AWS provides a management portal for vCenter, which actually integrates within vCenter, and through the console you can actually connect to your VMware environment and also connect to AWS, and from there just move your virtual machines into AWS. So there are several ways you can achieve this, and we talk about different strategies here. One is to forklift. That means as your data is running within your own data center, as your application stack is running, you just replicate that only on virtual machines. This may not be the best way, but could be an easy way to get started. But we recommend that you utilize some of the best practices of optimizing. Now, optimizing means, as a first step, when we say embracing the cloud, you could actually run some scripts to start and stop your instances when you don't need them. Typically, this is not done within your data centers, but on AWS, you get a lot of benefit. You can save a lot of costs. And further on, you can use techniques like auto-scaling, using S3 for storage, for your blob data, could be images and files and stuff like that. You could use S3 and save on a lot of cost and also achieve a lot of scalability. Several migration tools available. I'll not go through all of them. I've covered some of them as I've discussed today, the migration tools. But you will have access to the slides after the webinar week is over, and you'll be able to take a look at all of this as we send you the slides. But I'll just take a moment to talk about some examples of customers that are running enterprise apps. And we have a lot of examples of customers running a whole lot of different applications, internet apps and media. But I've taken a list of customers who are running purely enterprise applications, and most of them in the SAP, Oracle, and Microsoft space. So Kellogg's, you see, they run SAP HANA on AWS. Macmillan Education, so they are a customer based out of India, and they deployed their SAP CRM on AWS. So they started running a business critical application on AWS before running anything else, and they benefited a lot with improved availability on AWS. Lionsgate is a big media and entertainment company out of the United States. They run SAP as well as Microsoft workloads. Dole Foods, they run SharePoint. Similarly, you have MB Shaw Media, they run Microsoft workloads. And the bottom of the list is customers that run Oracle applications. So Sujeti runs Oracle applications on AWS. So there's a use case on how they built DR for the Oracle databases. Amazon, who's of course an internal customer of AWS, Amazon uses Oracle Secure Backup to back up all their Oracle databases into AWS. So there are a lot of cost savings achieved through that. You can read about it on the case study page. And Sage Manufacturing, so they run Oracle e-business suite on AWS today. So these are some customer examples. As a next step, I would request you, if you've not already signed up for an AWS account, do create an account and do take advantage of a free tier. There's a free tier that lets you sample certain services within certain limits free of cost, and you could test your AWS resources there. You could also use something called as the AWS test drives, and a lot of partners and vendors have put their pre-configured solutions on AWS for customers to test it at no cost. So you could go to test drive, you could see a listing of different solutions. It could be solutions based on SAP or Microsoft, for example SharePoint, or it could be Adobe, it could be Oracle apps. You could just test it at no cost from these partners, see how it works, and this will all work within AWS, within the AWS environment. So you have a first-hand experience of how this application runs on AWS. So there's a lot more webinars that we are running as part of this webinar week. There are a lot of online resources that you can leverage for training. There is classroom-based training and also AWS certification. Having said that, I conclude my talk today, and I will pass on control back to the host, Fiona. We really thank you for joining us today. We really appreciate your time in spending with us. Do continue to leverage other webinars that we're conducting throughout this week, and do give us your feedback and write to us if you have any questions. Thank you.